Hey folks, how's it going? Mr. Murray coming to you with a little do now here on um, the law of cosines. So this is for March 18th, 2020. Before attempting this, please make sure you've done the March 17th lesson. That lesson may take you more than one day. If it takes you like too long, that's totally fine. You just split it up into a couple days, but just please make sure you've gotten through that packet at least to the modeling section of the video before you attempt this do now activity, okay? Because this is based on the law of cosines. Okay, so here's the situation. Officer A and Officer B head out in their cars from the Milton Police Station at 3 p.m. Officer A travels 5 miles from the station, while Officer B travels 7 miles from the station, as shown. All of a sudden, Officer A calls Officer B for assistance at a speed of 30 miles per hour to the nearest minute. How long does it take for Officer B to arrive at Officer A's location, assuming that Officer A doesn't move as B is driving to A? Okay, because then if it moved, then we couldn't like set up a triangle, because then it would be, we have to think about that. Okay, so we're going to assume A stays fixed. So in this diagram, if you see the modeling section of the 313 packet, and especially the video on that, you'll understand what's going on here. This represents due north. So as in, if this was a map, north, okay, from north, A is 15 degrees and B is 140 degrees, okay? So what I want you to do, again, first of all, please make sure that you've watched the background material on this and that you have 313 available to you, so you have the law of cosines available to you, and that packet is complete. So please make sure you have that done, and then assuming that's done, please pause the video, try to solve this problem. Again, we're finding the number of minutes to the nearest minute it takes B to reach A, and then when you're ready, unpause and I'll show you how to solve the problem. All right, so here we go. So I have to actually edit this, just delete this little typo there because I forgot to adapt that typo. So here's basically what we have here. The first thing that's tricky is setting up the triangle. So basically we know that this is 140 degrees from north. This is 15 degrees from north. So this is essentially the triangle that we want. Let's see if I can highlight this in purple. Okay, here's my triangle. I know that A side is 5 miles. This side is 7 miles. Okay, now specifically though, this is 140 is not the whole thing, right? We have to take that into account. So I'm just gonna do my best. This is just like a freehand copy. So this is 5. This is 7, right? This is where A is located now. This is where B is located, and we'll call like C central command. Okay. So basically, we need to figure out what this angle is, because if we need to solve for this side right here, let's call this the distance, then I need to know the other two sides and the angle opposite it, because that, if you look at the law of sines in 313, to find any side, you need the two other sides and the angle opposite the side you're trying to figure out. If you don't have that, you don't have enough information to plug into the law of sines, so you can't solve, rather the law of cosines. Sorry if I said law of sines at any point, I mean law of cosines right now. You need that information to plug into the law of cosines. So this whole angle here, right, again, this is due north. You can imagine due north here. The whole angle is 140, right? This piece is 15. So then that makes the opposite angle from the side we're trying to find 125 degrees. You're just subtracting them, right? Because if you look at the blue, it's the whole angle, but I don't want that. I just want the inner piece right here. So I subtract out this little chunk, and I'm given that that chunk is 15 degrees. That's why I need the 15. Okay, you might have seen it doesn't really seem like it's playing a significant role in the problem. That's the role it plays. So now I'm going to activate the law of sines. So know that the distance squared is equal to one side squared plus the other side squared minus twice the sides times each other times the cosine of the opposite angle. So this we do in our calculator. 5 squared. Okay, please make sure you have access to a graphing calculator, or at the very least a scientific calculator. The scientific calculator will work for this because it will do the sine, the cosine, and the tan. If you have neither of those, please make sure you have access to wolframalpha.com. Put that there. It's in the Google doc as well. wolframalpha.com. Okay, so 5 squared plus 7 squared minus 2 times 5 is 7. Cosine 125 is approximately. So we should round the. Remember, we usually round our intermediate answers. Let's try to round it to 3 decimal places. It doesn't specify that, but that's something that you hopefully would have seen if you worked through that packet. So the distance is approximately, we'll round to 1 decimal place, 10.7 units miles. Okay? So in other words, the distance that B needs to travel to get to A is 10.7 miles. So are we done? We are not, because we're asked how long does it take. So just make sure, and if it helps to always, I always like to underline the question if I don't know. So if it helps you, think about that. So in general, distance over time is equal to, we could say speed. It's not, it's kind of like more like velocity, but we'll say speed. So that means that the time it's going to take is equal to the distance you have to travel. Okay. Or rather, the distance you have to travel over the speed at which you're traveling. Sorry, I gotta solve that. All right. So if I go 20 miles per hour, if I go for 40 miles, it will take me 40 divided by 2, or 2 hours. In this case, I need to travel 10.7 miles. And I'm told, it's actually given, if you look, I'm going 30 miles per hour. Let's back that up. Miles per hour. Okay, so the miles will cancel and the hours will come up if you're doing unit, like dimensional analysis. So I get 0.35. Actually, for this purpose, I do actually want to save. I realize, let's try this, because we do need to save the value of D to be technical. That's not rounded. So let's get the unrounded value, 10.684. So what we should really be doing, my apologies, is we should be doing that. So 10 point, because I just realized I'm going to need, this time is going to be another intermediate value. And when I say intermediate, I mean like a step in determining the final. Because remember, the more you do, sorry, not 10.730, the more, I gotta just get this before I start talking. Okay, whenever you round, remember we talked about how whenever you round, you create an error. So the more rounding you do, the more error you make, the farther off your answer is from the correct answer, right? Any rounding is essentially introducing error. So this means that it's going to take 0.356 hours to travel that many miles. Okay, so if I take 0.356 hours, and I want to know how many minutes that is, I multiply by 60, and I get 21.4. Now I round to 1 minutes. And I need to round to the nearest minute. Okay, we're asked to round to the nearest minute. So we're going to round to 21 minutes. So it takes Officer B about 21 minutes to travel about 10.7 miles to Officer A. Okay? So what did I do here? I started with my problem. I set up a triangle using the given information, the fact that A has gone 5 miles, the fact that the B has gone 7 miles, okay, and the known orientation that I was given in the diagram, so that was important. I made my triangle, okay, and then I identified the fact that I had the side opposite the angle, and I had the two other sides. I used that to set up. Remember, this is the law of cosines. Okay, I know it's the law of cosines because you can see there's the cosine. Okay, so I plug in the stuff I need to plug in, solve it out. Again, that was done with my calculator. Remember to take the square root because I want the distance, not the distance squared. And also remember to hold on to the 3 decimal place answer. So 10.7 is okay for reporting out, but remember for intermediate steps, when I'm actually going to use it to find something else, let's round to 3 decimal places to reduce the error caused by rounding. All right, so hopefully you found this video to be informational. Hopefully it helped you. Please make sure if you don't understand at all how to do this problem, that you go back and look at the lesson, the previous lesson, because the lesson from 3/17/2020, that was the law of cosines. Okay, so that was also called lesson, at least as of now, lesson number 2. So please make sure you review this. All right, I'm here to help you. I hope to be doing a Google Hangout soon. All right, folks, so stay positive, keep at it, and remember, you can do it. All right, thanks for tuning in. Have a wonderful day, and don't forget to love math.